Okay, so this time I'm gonna give you a taste of how the Korean SATs, the math section works. So in Korea we have the SAT on November of every year, and we get semi-tests about 4 to 5 times, I think. I'm not exactly sure, but yeah. This one is the one which we had in September, right? This is one of the questions out of 30. This one is handling. Right now, I think it's geometry, I guess. It took me about 2 minutes to solve it, like when I first saw it. It's not that hard. So let's see. Now, this this plane beta and this plane alpha is perpendicular, I think that's what you call this, right? 90 degrees. And yeah, that's that. And what happens is this sphere is an S, which the radius is 3, and 3 of this S, sphere 1, sphere 2, and sphere 3, which all have the radius of 1. And all these spheres are on top of this plane alpha, so it's touching it on one point. And to add to it, this sphere and sphere 1 and 2 are all touching at one point, and this sphere and sphere 2 and sphere 3 are touching at one point. So the question is asking us, okay, so if we take a plane that is perpendicular to plane alpha and crosses this center and this center, so something that looks a bit like this, I guess, and this plane intersects with sphere 3 and makes a shape, and we're to make that shape and cast a shadow of it to plane beta, and we're supposed to know what's the surface area of that shadow. Now you might think it's hard, but bear in mind it's not quite. So to simplify the question, how do we get the surface area of a shadow? It's pretty simple. So you get one shape here, and you just draw a shadow, right, on a plane. How you get it? You get this area, which we'll call S, and then what do you call it? You move this plane up, and it intersects at one point, and you get the cosine of this angle times S times cosine theta equals this S prime, which would be the surface area of the shadow. So what we would have to do is we would have to get the angle in between the plane that would be created, which is crossing these two, and crossing these two. And I thought about it, and I got it that the center of S1 is right here, center of S2 is here, center of S3 is here. So these spheres are all the same. So if we were to make this pair and this pair, it would be exactly the same. We'll say the center of S is C. We'll say the center of sphere 1 is C1. Center of C2, center of sphere 2 would be C2. That point. And then it would also look the same if this was C2 or C2 or C3. So how are we supposed to get this angle? Well, there is a weird bit that this isn't actually right. This C is supposed to be the center of this run down to be parallel to these 3 center points. So to get that, what I did was, let's see, you get S and S3, or S or S1, or S or S2. So there's a sphere like this is S, and another sphere which is on the plane alpha, and its radius is 1. There you go. you connect these. So this was radius is 3, this is radius 3, 1. We do this, and we do this. And we know that this radius is 1 right here, and this was supposedly 3. So that'd be 3 minus 1, so that's 2. So we get this one. This is root, that's 16 minus 4, so that's 12. So no, this is 2 root 3. So we get 2 root 3. So basically, this would be 2, where am I talking? Okay, yeah. So this would be 2 root 3. So center is the one which is come down and is on the same plane as these 3 dots, centers. If this is 2 root 3 and this is 2 root 3, you know, if you look at it, it's the same distance from these two, so this must be the same length, right? Do you agree? Yes? And right here, what is happening? What is happening with these two? Well, right here would have to be a sphere which would have the radius of 1. Right here would have to be a sphere which has the radius of 1. Right? So this would be 2. This half would be 1. We draw a right angle here, and you get the angle of this. Cosine theta, this bit, if this is theta, cosine theta would be 2 root 3, 1 over 2 root 3. And sine theta would be root 11 over 2 root 3, yes. Right, we get this, right? And then, right. So let me draw this bit out for you. It would be a bit like this. And So we would get the surface area about right here. And we want to bring it down here. So basically, this bit was theta, right? This bit was theta. So we want to get the cosine of this angle right here. This would be 2 pi minus, pi minus 2 theta. So we want to get cosine pi minus 2 theta. And if you think about it, we draw a circle. We get pi and then whatever 2 theta is, that would equal to negative cosine 2 theta, right? So how do you get negative cosine 2 theta from these two? It's pretty simple. This is an equation you get from when you do like this equals something like this, like, you know. Well, it's pretty complicated, but it's easy once you know. I'll tell you. Cosine 2 theta equals cosine squared theta minus sine squared theta. So this would equal 1 over 12. This would equal negative, well, because this minus here, it's negative 11 over 12. This would equal negative 10, 12 equal negative 5, 6. So we wanted, cosine 2 theta is negative 5 over 6. So minus cosine 2 theta would equal just 5 over 6. So we have this cosine 2, what am I doing? We have this cosine 2 theta minus this equals 5 over 6. But what does this mean? It means, we go over here and we look at this. It means this angle, right? And what does this angle correspond to in the thing which I said? Is this. So all we have to do now is we have to get the surface area which has been created, and we have this, which was minus 6. No, it was plus 6. Yeah, it was plus 5 over 6. We got this. So we need this. Well, it's pretty simple. Well, I'm saying it's pretty simple a lot, but it might not be. But you get these two spheres. You connect the centers of it, and you make a plane which is perpendicular to plane alpha, and it would cut it right through the middle. So it would just be a circle, right? It would be a circle with a radius of 1. That's all. right? Because if you think about it, there's a sphere, you cut it through the middle, it's same, so yeah, it'd just be radius, and it would just be a circle. So what is the surface area of a circle that has a radius of r? It's pi r squared. You can get this through, oh well, it's boring, but no, I'll just write it just in case. So you go from 0 to r, you get the surface area, I guess. Like, I don't know how you call this in English, but integrated? I'm not sure, man. R squared minus x squared dx times 4, because this right here, I'm not sure, I don't remember right now, but this is r, we're getting this bit, so we have to times it by 4 because there's 4 slides, you know, to make a circle. Yeah, so, and r was 1, so, you know, this would be equal pi, so we just have to do pi times 6 times 5. This would be the surface area of the shadow which has been cast on plane beta by a plane which is perpendicular to plane alpha and is crossing the centers of sphere 2 and sphere 3, which is intersecting sphere 3. So this circle right here, like a bit like weirdy, yeah, this is just damn damage. We get this one. That is 5 pi over 6. And what the question, like, this is done on an OMR card, so it has to be whole round numbers. So what it asked us, to make it so that it looks like this, but these two are not non-divisible, and then you do p plus q. Yeah, so these are non-divisible, you can't divide it anymore, so you do, what is it, q equals 5, p equals 6, so p plus q equals 11. Yeah, so this was a test which we saw on September, preparing for the current SAT in November.